So let's do this. Okay, so we have these three, and we're going to solve them using the quadratic formula. Okay, so let's do that. Okay. For the first one, as you can see, right, it's already in standard form, which makes it a little bit easier. So what we're going to do now, right, is get A, B, and C. So as I have here, A is 1, the leading coefficient. B is -4, right? The coefficient of x. C is -8. Remember, you always include the negative, okay? If you're subtracting. So when I plug it into the formula, the quadratic formula, we get this. Right? So again, B is -4, and we have negative B here. So you would have a double negative, right? Which is addition. Okay? So we have a double negative there. That becomes addition. Okay? Now, we also have -4 squared, which is 16. Right? And we have -4 times 1 times -8. So that's why we have plus here. We would have -32, which becomes plus 32. And so we get this. I mean, technically this is enough, but let's simplify that a bit. Right? We do have our two solutions. But, it's good to simplify if we can. Namely, 48 has 16 as a factor. Right? The square root of 48 is not simplified. How do we know that? Because 16 is a factor of 48, and so it has a factor besides 1 that's a perfect square. And so this is what I'm doing here. Right? We factored out that factor that's a perfect square. Square root of a product is the product of the square roots, and so we get this. Square root of 16 is 4. So altogether, if we plug this in, our two solutions look like this. Well, this is the first one. I replaced the square root of 48 with 4 radical 3. And then just like before, I rewrote it as a sum like so. It's kind of like going backwards when you add fractions. You combine numerators, but you leave the denominator alone. And so we get this after dividing. And so this is the other one. The only difference is that where I have addition here, we have subtraction. So that's the only difference. Okay, let me get to the second one. So this one, again, this is what you use in the quadratic formula. I mean, if you had to factor this, that might be kind of tricky. In fact, we have our A, B, and C just like before, and then we plug it in to the quadratic formula. So we have this. Since B is negative, just like before, we have negative B, right? Which is, which is this. So also, this, and also under the radical here, right? -7 squared, okay? That's 49. We have here we have -40. So -40 is plus 40. 89 itself is actually one of those numbers that are prime. Its only factors are 1 in itself. I actually didn't know that. I had to look it up myself to see if I could simplify this. When I give you something on a quiz or test, I'll make sure you can't simplify it if I don't tell you to simplify. In other words, this is our final answer, is what I'm saying here. So this would be a question where I do not ask you to simplify. The last one, let me see if I can quickly do that. I divided both sides by 40 just to make it a little bit easier, because 4 is a factor, excuse me, not by 40, by 4, because 80 has 4 is a factor of 80, and so we get 20. And then I subtracted, as you can see, to get x squared minus 20, so it's in standard form. And then from here, I did the quadratic formula. B is not there, right? The x term is not there, so b is 0. A is 1, C is negative 20. And so I know I'm going through this kind of fast because I want to finish. And so we get this. And as before, square root of 80 you could simplify because 16 is a factor of it. You get 4 radical 5 and so on. So just letting you know, again, this will be in the notes, which I'll post. So okay, I know I went through it kind of fast, but it's 1:50, so I have to stop here. All right, so that's it for today. Sorry for going through the end kind of fast, but again, it's kind of